Do you know what is mean by charge and how the charge is the how the fundamental property charge will make sure that whether the atom need to behave in one particular way or whether the atom need to behave in another way. So let's today discuss how the charge, the very basic fundamental thing acting in an property or in an body to change the behavior of the things. So let's discuss what you mean by charge. So every time when we are going to discuss an depth subject or any kind of engineering subject, we need to start from the very basic scratch. So we are going to start from the very basic scratch, that is a charge. So which is nothing but a property of the body due to loss or gain of electron. So let me give a very fundamental definition, that is property of a body, maybe anything, that may be anything, molecule or anything, that may be anything, so we are not worrying about it. So any body that if it is losing or gaining electron, so property of the body due to loss or gain of electron, loss or gain of electrons. Okay, so you guys may ask question, what do you mean by electrons? So let me take an atom, atom for a reference. So let's consider an atom here. So let me draw a simple atom structure for you guys. So atom is nothing but a fundamental property, like similarly how we are discussing charge. So that is another one fundamental property that we will be discussing. So if you guys have any doubts in the atom, what do you mean by atom, I am suggesting you guys to watch my semiconductor physics lecture. So there I have clearly explained what do you mean by atom, some Bohr's theory behind it, what are the fundamental assumption behind Bohr, after the Bohr how the things are converted into different things, Schrödinger equation, Bohr's equation, everything I have dealt there. So I am suggesting you guys to watch that lecture also. So this will be how the atom structure will look like. So electrons will be revolving around it. In the center there will be a nucleus. In the nucleus, proton and a neutron will be there. So this is how the thing it will be there. So proton is nothing but a positive charge. So proton is nothing but a positively charged item, whereas electron is negatively charged items. So which is nothing but a behavior. So the fundamental charge property. So which will be negatively charged. So electrically neutral. So generally number of atoms which will be number of electrons which will be equal to number of protons. So this will be electrically neutral in the normal condition without any cause and effect. So this will be electrically neutral. Okay. So for an example, if atom losses. So if an atom losses electron. So what happen? Atom is losing electron, losses electron. So then what will happen? The positive charge will now increase. So positive charge. So two protons will be there, right? So that the charge will be more than the number of electrons. There will be only one electron. So then being wants the domination of positive charge will be there. So the net is will be net thing will be positive charge. So this is how when an atom loses an electron, the charge will be changed to the positive charge. So we already dealt in the p-type substance, right? P-type. So how we mention the p-type semiconductor is that the positive charge above that there in sorry, that is an electron. So this is for n-type. So n-type how we maintain is the positive charge plus electron. So this will be called as n-type. So why this is because is it has an one electron excess. So if it is losses this one, then this will be become positively charged item. So that is how we generally represent the n-type like this. Whereas in a p-type, we mentioned that as a negative above subscript which is whole. So this will be called as a p-type. So in semiconductor physics, I have detailedly explained this one. I am suggesting you guys to watch that also. So this is how when an atom loses electron, that will become a positively charged atom. If an atom gains electron, what will happen? If an atom gains electron, then what will happen? The negative charge quantity will be more. So positive charge will be less than the negative charge. So negative charge. So means the net thing will be negative. So net negative charge. Okay. So thing is that so this is how the property will be stated here. So the charge Q. So Q will be there will be charge of an electron. So it should be 1.6 into 10 power minus 19 coulomb. So this is how the fundamental property of this one. So SI unit will be coulomb. So COULOMB, the coulomb, which will be the SI unit for the charge. So charge on a body which can be calculated Q, which is equal to plus or minus NE. So E is the fundamental property, N is the number of thing. So number of integer, the number of electrons or depends on that. So N will be a integer. So that will belong to integer. Okay. So Q is quantized. So quantized means it will be taken into positive quantity. So always we prefer this value. So Q is equal to positive Ne. Okay, so this is one important formula. So mass of the electron. So electron will have the charge property will have the mass, right? So that will be, how is that, 9.1 into 10 power minus 31. You guys guess it. How the weight will be? It will be 0.00030 zeros and then 91. So you see how much the weight will be that. So this much tiny property only we will be studying here. Okay, so I hope charge is understood for you guys. So we guys from the, even I know from the ninth standard itself we are studying the law of conservation. So similar to that, the law of conservation will count for charges also. Charges can neither be created nor be destroyed. So charge can neither be created nor be destroyed, but can only be transferred from one form to another. Can only be transferred from one body to another body. Okay. So used in many problems, like, so law of conservation is very important. So this is follows the thermodynamics first law, right? So that is only. So this is how some basic representation. So let's now get started with the important thing, that is what you mean by current. So let's take a material. So that may be semiconductor or maybe conductor, anything. So let us take a let me get a square shaped conductor. So what will happen if we connect the battery or terminal of supply? Then what will happen is the electron will be start flowing there. So the electron will be flowing. Because of this electron flow, the reverse direction will be take the quantity that will be quantized term, that we will call as the current flow. So we will be representing that in the term of current flow. So let me explain that in a clear way. So this is how when we connect a battery to the device. So let's take this as a semiconductor or any kind of conducting material. So if we connect a positive battery supply like this way, so here positive terminal and this will be negative terminal. If we connect like this, then what will happen is that the electrons will be start flowing. So how the electrons will start flow is that the electrons will be flowing in this direction. So let me write it in this way. So electrons will flow in this way. This will flow. It will flow into the conductor, and it will pass through the material that what we are giving, and it will be coming out from that also, because there will be net flow need to be there, right? So this need to be in equilibrium state. So this will flow in this way, and then it will become, and it will be lying in the positive terminal. So it will be, at last it will go and start. So this is how the electrons will be flowing in the material. Okay, so if electrons are going in this way, the opposite direction which will be considered as the conventional current flow. The current flow which will be in this direction. So red marks I'm making, right? So that will be the conventional current flow, the opposite direction of electron flow. Okay, the electric field which will be directing from positive to negative terminal. So here it is positive, here it is negative, right? So it will be directing from positive to negative terminal. So it will be in this direction. So the electric field will be in this direction. So the electrons will be moving in the opposite direction to that. So electric field will be in this direction. So these are some fundamental things I will explain. So next lecture, next topic will be the voltage and the potential difference electric field only. I will explain those things. So for now, just understand the electron will flow in the opposite direction to that thing. So here the thing is that this will be the flow of electrons. So this will be the flow of electrons. So when a battery is connected across a conductor, then the electric field is produced from positive to negative. So when battery is connected, what will happen? When battery connected to conductor, as a next state, what will happen? Electric field will be produced. Electric field will be produced from positive to negative. Because of this electric field, what will happen? The electron will be drifting from, so electron drift from drift in opposite direction. Electron drift in opposite direction. This drift and diffusion concept I have already explained in the semiconductor physics. So please go and watch thing. So that is what, guys, I'm stating that thing. There is will be interconnection between every subject in a EC and EEE. So now you see in the first lecture itself, I have plenty of times I've said about the electronic device. Means there is a strong correlation. So if you guys once understand the network theory and EDC those subjects, then our analog electronics will be very much understood for you. EVLSI, CMOS will be very much understanding. That's why I will be strongly suggesting the students to learn the basics very much thorough. So then they can easily understand the upcoming subjects in the near future. So that's why I will be stressing more about the fundamentals. So electrons will be in the opposite direction. Because of that, what will happen? The current will flow. Okay, so this is how the current flow will happen. This is the flow. The force on charge will be calculated, which is F vector, which is equal to Q into Q E vector. So this is how the force can be calculated. In a conducting material, the large number of free electrons are present, so that the Q will be less than 0. The force will be opposite to that of the electric. So this is also one of the reasons why electrons are drifting in the opposite direction. So electron experience a force and flow opposite to the electric field. So this flow is called drift. So that I already mentioned here. So this flow is called drift. So the current can be also calculated in the term the time rate flow of charge is called current. So dq by dt. So amount of charges that is flowing over the time can be calculated as the current. So this is how the fundamental relation of current to that of the charge particles. So please make a note of it. So it is nothing but a rate flow of charge. So rate flow of charge. These are a very simple small definition but which has a huge meaning, guys. So please make a note of it, everything. So which is nothing but a rate flow charge. So charge crossing a particular cross section in a time which is called as a dq over the time dt. So the conventional direction of current will be opposite to that of the positively charged. So it means opposite to that of the electrons that is moving. So conventional direction of current flow is in the same direction of positive charges but is opposite to that of electric field. This one is very important. So the conventional direction, the direction of current that we are taking, right? So that will be in the same direction of positive charge. Conventional direction of current. Conventional direction of current is as per is in same direction of positive charge. Is in same direction of positive charges, but in opposite to that of electric field. Electric field, not electric charges, positive charges, and opposite to negative charges. Okay, so this is one important thing, guys. Please make a note of it. So that's it, guys. So this is how the current will flow. So let's now start our discussion with the voltage. So voltage can also be called as a potential difference. So we guys might discuss everywhere voltage, potential difference, but we have to understand the core difference, guys. So what do you mean by voltage? What causes the electrons to flow? Everything I will explain here. So from EMFT or electromagnetic theory, we know that. So from EMFT, electromagnetic field theory, we know that VA minus VB, the potential difference between 2 points, which will be negative integral of over the area B to A or A to B, E vector over the length dl or the unit area length. So this is how the potential difference can be found out for the electric field over the distance. Means the 2 point potential difference. So always electric field is distributed from higher voltage to lower voltage. So here one more thing is that, so always electrical field is directed from, always electric field is directed from higher V to lower V. So higher voltage potential point to lower voltage potential point, lower V point. Okay, so the E can also be written as the negative gradient of V. Okay, so we will be explaining this term in EMFT, so that course I will start later. So for now, make a note of this one. So there is always a potential difference between two terminals of the battery, which causes the electric field from positive to negative, which causes the current to flow in the same direction. So that we already discussed here. So this one, so that is what this flow only they are making. So the battery is connected, right? So there will be a potential difference. So there will be a del V, not del V. So there will be a this V. So there will be potential difference. So because of the potential difference, the electric field will be created. Because of the electric field, the charges will move in the opposite direction. The opposite direction of charge electrical movement, which is considered as the current field. Okay. So current always leaves the positive terminal of the battery and enters the negative terminal that we already took there. So the current flows from the higher voltage potential to lower voltage potential. The electrical field, the electrons flow from lower voltage to higher voltage. Okay. So potential difference means nothing but, so let me give you one more simple definition. So potential difference, so let me write here also. So potential difference is nothing but work done in moving the charge particle. Potential difference is work done in moving a charge from A to B. So from our point we are taking, right, so A to B per unit charge. So we are that normalizing that one with the unit charge. So means the VA minus VB can also be written as work done divided by charge. So this is also a very important formula, guys. So we will be relating these formulas in other equations. So next class we will be discussing more things on these, the electric field, potential, and everything we will be discussing. So there I will relate these formulas. So don't worry, guys. So for now, you make sure that all the fundamental properties and charges you are able to understand this. So please stay tuned, like, share, and subscribe channel so that you guys are learning along with me. So thank you, guys. Stay tuned.